Yay, good morning.
Good.
Happy Saturday, Igor. Nice to see you.
Yeah. I have Sunday today. Yeah. I don't know, but
Oh,
yeah,
oh, really?
hap-
Oh, wow. I didn't know it works that way. Nice.
it does. It does. Yeah. But yeah, how is your Saturday, Alex?
Yeah, I just started. It just started. It's very hot these days in Amsterdam. 30 degrees last warm summer last week this year. So trying to enjoy it, but not a big fan of the heat. How about you?
Poor guys. Poor guy. I people say that we have a second, third heat. Honestly, I didn't really feel it, although it feels. Let's see how.
It still feels like a first heat wave. I'm really glad for you, Igor. You breaking up a little bit.
Yeah, I'm sorry for this. Always my internet connection is not perfect, but I'm trying. I'm trying.
Yeah, we can see that. Thanks a lot. And yeah, welcome everyone to our stream, Saturday stream, XT Code Hour. Just to remind you about what are we? We are XTechnology, a community of people like to talking about technologies, not only talking but also doing something and exploring lots of stuff. Yeah, and we explore different topics. I think today we continue the one that we started last time, and that was actually consists of two parts. The first part was to solve one puzzle with a Python on LeetCode, and the other one was yeah, let's see, explore some project that I'm currently thinking of. So that's the plan for today. Thanks for joining. Thanks for watching, sharing with your friends, and yeah, we really appreciate that. So yeah, shall we start, maybe, Igor?
Yeah. Thanks for the intro, Alex. Yeah, sounds like a great plan. Last time we managed to solve one medium problem on LeetCode in about 40 minutes. Oh, that's kind of my level currently. So today, I guess we could try to do it in 35. It would be an achievement. And you see, now I have 98 LeetCode problems solved. That's a great
Okay.
number. Maybe
All
in
right.
2 sessions.
Let's make it 100. Yeah.
Yeah,
Sounds
so
like a good plan.
yeah, I guess we could. Yeah, last time I went to this page number 6. Tell me some number which is bigger than 6.
37.
37. Good number.
Yeah, that's last two numbers of my PIN code for the card.
Okay, tell me some other number. Okay, next time.
Next time, yeah.
37. Yeah. Okay. Okay, so what do we have here?
What coincidence? Yeah. Okay.
Side minimum sideways jumps. Wow, that sounds. Do you think it's? I don't know. It sounds fun. Minimum sideways jumps, and the exception rate is 50%, which makes it probably complicated.
Mm-hmm.
But who is afraid of complications? Not we.
Not me.
Definitely not. Yeah,
Not
definitely.
And good luck.
Oh my God. Wow. Okay. Oh, yeah, thanks.
Oh, it's like doing a game, the whole game. Interesting.
Yeah. Now I'm not sure. Okay. Well, let's jump into sideways jumps. Okay, there is a 3-lane road of length n that consists of n plus 1 points labeled from 0 to n. Okay. A frog starts at point 0 in the second lane and wants to jump to the point n. However, there could be obstacles along the way. Okay, so far I think I get it. You are given an array obstacles of length n plus 1, where each obstacles ranging from 0 to 3 describes an obstacle on the lane. Okay, so is like a 2D array. Okay, so if obstacles equals 0, there are no obstacles. Okay. There will be at most one obstacle in the 3 lanes at each point. Okay, for example, if obstacle second equals 1, there is an obstacle in the lane 1 at point 2. Maybe. Yeah, so here are 3 lanes. The frog starts at the 0's position. And then there is an obstacle at every step, at least in 1 lane, as they say.
Yeah.
So I guess
didn't get so far, like on which lane is there obstacle? I don't know if that matters, but
sorry?
On which lane is the obstacle? I didn't get this rule.
I think so. So here is the array obstacles, and I think.
Oh yeah, the number
this means
okay.
Yeah, so I think 0 means no obstacles. 1 means it's in the
number
first
of lane.
lane. Yeah, I guess that's the number of lane.
So
basically, there is always something besides. So in the first and in the last, there are zeros, and then it is something. Okay, and I guess we could jump, but let's see. So at each point, for example, the frog can only travel from point I to point I plus 1 on the same lane if there is not an obstacle on the lane at point I plus 1. Okay, so we cannot jump on the obstacle. That makes sense. To avoid obstacles, the frog can also perform a side jump to jump to another lane, even if they are not adjacent. So we can jump over a couple of lanes, even if they are not adjacent. The frog can also perform a side jump to another lane, even if they are not adjacent. Okay, so lane, right? So basically from here, we can jump to here. Okay. Yeah, for example, the frog can jump 3, so from lane 1 to, from lane 3, to lane 1. Okay. Wow. Return the minimum number of, oh my God, minimum, I hate it.
Wow.
The minimum number of side jumps that frog needs to reach any lane at point N, starting from lane 2 at point 0. Oh my God.
Number of side jumps. Starting from number. I didn't get the last point. Starting from a number, so for each step, we want to keep this information.
Which one? Sorry.
Minimum number of side jumps in your lane at point N.
Yeah, so meaning that we can arrive here or here. Or here.
Oh, okay.
That's how I understand it.
And we need to calculate a number of side jumps.
Yeah, and that I'm not sure. No, I think the minimum, the overall number of side jumps, I guess.
To reach any lane at point, okay.
Yeah, so we just need to get to the finish, but in any lane on the finish.
Yeah.
And we need to calculate side jumps. But do I understand correctly that any side movement is a jump, right?
Yes.
So this is also a jump. Okay, so basically we need to calculate the amount of lanes we changed to the side, or and then the minimum amount. Oh my God!
Shouldn't be that hard, huh?
Yeah. So I remember this kind of tasks, like then find something minimum, but I don't even remember how you do it. I guess you create the tree kind of, and then something.
What if we know number of obstacles for each lane and we took the minimum number of that? Would it mean basically that that would be approximately our number of side jumps?
I don't know. For example, this use case, so there are 4 obstacles.
Yeah, but for each lane is 2, 2, 0. So we don't need to side jump.
Yeah.
If we go by this lane, basically. And if we have a number of obstacles, like let's say we have 2, 2, 1, right, or 2, 2, 3, it doesn't matter. So we have obstacles on each lane. That means that we want to keep being on a lane with a minimum obstacles, and we need to jump to other lane every time we have an obstacle.
Yeah.
It's
Yeah.
not an easy exercise, I must say.
No. I guess we cannot even say that we want to. So I think it doesn't make sense to calculate the lane obstacles, because it could be like here is 1 and there is nothing, but we always have to keep this lane. So it's I think it's I don't know how you call it. So every time we have 3 possibilities, and every next time we have again 3 possibilities, and we somehow have to keep track of all of it.
Yeah. What if we, the other idea, what if we keep side jump into the lane with the minimum obstacles on the way? Every time we choose a lane with the minimum obstacles left from this step.
That might be true, but for example, what if, so in this case, it's not working, but for example, here, so let's say we are now here, and which lane should we choose? Because there are here 1 and here 1. They are equal.
From this one, we cannot select much, right? Or you mean from which step we need to select? From step 2?
No, let's say we are already in step 1. So
yeah. So we cannot really jump to lane 1, and we cannot stay on a lane 2. So we don't have option. Really.
So I guess we don't really have options. So the only option is to go here.
Yeah, and if we have ambiguity, I guess we can choose any. That would not. But I mean, that would work. But I'm not sure if that's going to be a minimum. Sorry.
Yeah. But actually, if we just go in the possible direction, wouldn't it solve? Probably wouldn't, right? So, because let's say, so in this example, we just follow the possible steps because there's nothing else we can do. In this one, it's the same. We just follow the possible steps. By the way, regards from the cat. And in this here already we have 2 options. We can go here or here. But if we go up, then on the next step we need to jump again. And that is already not optimal. So we cannot just follow the possible steps. So we need to somehow track. I don't know. I think that's kind of the thing that should be solved recursively. If I'm not, I'm just trying to remember that kind of tasks. I think you kind of have to recursively specify these functions. But well, that's kind of that let's say you're in the very last step. And you have only a couple of options, and then you apply this function. And then if you're in a step before, you just apply the same function. And I mean the usual recursion.
Yeah, got it. Yeah.
But yeah, I'm not sure if it's the case. Discussions, similar questions. Okay, so the function accepts just the obstacles list, right? So let's just say we're in the last position. Let's pick. Yeah, okay, let's pick this one. So if we're so in the beginning we have this kind of array, and at the very last step, so when we are at the step number 3, our array looks like this, right?
In this case, we stay on a lane.
Yeah, in this case, we stay on the lane. So maybe that could be, well, will it always be the case when the next one is 0 that we always stay on the lane? It couldn't be 0. Okay, yeah, it couldn't be 0. I got.
Right. Every step has okay.
Okay. Well. Anyway, so let's say we wrote this function, and it outputs us the minimum amount of jumps, right? So let's say we have this function already written.
Is
And
it 2? Turn 2?
Yeah. So let's say on the first step, it is like this. I don't know, n min equals like this. Yeah, maybe I just put it from here to here, so it's not a part of the script. So the kind of answer for the task is like this, right? But that is also, it's the same as we have.
Call it without the last step. What do you mean?
Yeah, without the first, probably.
Oh, the first step. Yeah.
Well, where's my cursor? So it's the same as we have to do we have to save a position, probably, because we need to know where we are currently, right?
Yeah.
Maybe we would do something like position lane, which is the current lane where we are. Position where we are. And in the beginning it's 2, and then we always pass it. We shouldn't pass it because, so it's kind of, it's the well, yeah, it's a global variable, yeah, but let's just pass it explicitly to make it clearer. Position lane 0s, let's just do it like this. And then we have so n min equals the mean of, where's my cursor again? The mean of 2 things of this one position lane it's so okay, so we're starting here, and we can do 3 things, right? We can do either move here or move forward.
Yeah.
So if we move up, it will be still the same because we're in the same lane, addition lane 0. Or the second option will be, yeah, maybe we can say move up. And move down. That will be the same, but lane 3 or 2. And the other option, if we move forward, it will be position 1, and like this, move forward.
Nice.
But it could be, and all of them might be not possible at any given moment.
Yeah.
So yeah, like if possible. Okay, yeah, that's too much. So yeah, if possible, every step is if possible. So basically, we need to somehow put it into the code. So we always run. We always need to have the global position. Global position. Oh my god.
No, it looks good.
Yeah, it looks good. Yeah, so for now we didn't write anything within this function, but I think we need to specify it for the last step.
Yeah. If it's the last step, we can.
Yeah, so kind of something like if length of obstacles equals to 1, then
return 0, I would say.
Yeah, then return the previous, because we won't ever add any side jumps on the last moment. So if we're already at the pre-last position,
Yeah,
we need only to move forward and no side jumps added. It's always like this. Yeah, so we just return the current, oh my god,
result.
yeah, but result should be described via the function itself, isn't it? Shouldn't it be?
Yeah, I mean, you can put these states into the class, right? You can make the
Okay, yeah. Oops. Result. Okay. If obstacles and else return result, return mean of, yeah, basically these three guys. Yeah, we'll just put it. Okay. Inside jumps.
and it's missing something. I'm missing some calculation.
Yeah, we do. Okay, obstacles. Okay, obstacles. Maybe so if it's up and down, then the obstacles stays the same because we are not moving forward. Here we do obstacles 1, so we don't need the current one. Forward, but we also we need to keep track of the position and the lane. Oh, the position. Okay, the position we probably don't.
Yeah, position lane, you mean. We can also put it in the state of a class itself.
You mean to define the variable in the...
Yeah, in the class, like a result and the position lane, we could keep them. Why not? Should be once calculated. Or not. Or we do it recursively and we need to pass it in that way.
I'm not sure, because if we create it here, let's say result. So for now it's it should be infinite, right? Okay. Result. Okay, -1. Whatever. If we create it here, every time we go through the... wait, we have to update it, right?
Yeah, I guess we need to pass it then in this case.
But I guess
that's not a big problem anyways. We can create another function which will be doing exactly this, and we can change the arguments there.
Def calculate the jumps. So it should receive the current result, current jumps. Where am I going? Current jumps, current lane.
Yeah.
And I guess obstacles. Right?
Yeah, and obstacles indeed. Yeah.
Obstacles. Let's also call it current. I don't know why. Okay, and now, yeah, maybe we do it. Okay, so we do it in here. Jumps. Can we do this thing in here? Just thinking.
Yeah, I think we should move these all calculations in here. Yeah, so basically means jumps will call calc jumps, and the rest will be recursively in there.
I hope.
We missed somewhere in the increment of a result so far, but yeah, I guess you know that.
Yeah, so now wait. Calc jumps. What will that output? It should return.
Actually, you know, on line 16, line 15, you can also increase a result number and decrease obstacles. Like you can basically remove the first, the line 17, you got already cut the array of the next obstacles. Frozen, or it's what is you thinking? Oops. Igor. So what I was what I'm trying to say. Yeah. Now we got him. Yay.
Am I back?
You are back. Yeah, man.
Perfect. You were saying something about line 15, 16, 17, right?
Yeah. We could do the same like in line 17. We decrease obstacles, right? Because we move next lane. So we can do something like that because we already know that we're gonna be jumping, right? So we at least can increment the result number of jumps. So car jumps would be increased, I think, line 15 and 16.
Yeah. Yeah, I agree. But so that means that probably.
So you can just pass the first argument to this call, line 15, like car jumps plus 1, let's say. Current lane would be 0, right? Or 1, depending how it's called, called.
+1. Lane will be changed. Yeah, so it could be -1, but yeah, if we can go.
Not -1, but I think it's -1. Yeah.
Yeah, but if.
Or maybe we can also just name it like 1, 2, 3 in this case, but I'm not sure.
Yeah, we can name it 1, 2, 3, but we can do it only if.
Yeah, if it exists. Yeah.
Yeah, if car lane more than 0 and obstacles 0, so current element doesn't equal to 1. Oops. Will it be correct? To 1.
You mean in this sentence? You mean that there is no obstacle on the lane where we want to jump? Yeah.
Yeah. Then we can do this.
Why you have a comma on line 16? Is that correct syntax?
No, currently. Yeah, I was doing min of the arguments.
Yeah.
But I'm not sure now if we need to run the min. So maybe we don't need a mean. Let's say I'm just trying to think what this current calculate jumps function outputs us. It gets these three guys as parameters, but it also should change themselves.
Yeah.
So in this way, so it shouldn't output anything. It just should run and update the parameters within it, right?
No, I think it would return the minimum jumps.
So it would return the minimum jumps, yeah. Okay, let's try it. So calculate. So calculate minimum jumps, and that means return mean jumps, and mean jumps equals to mean.
Can you put the conditions inside the mean function, like if something, do something?
Yeah, that's what I'm thinking. But we can do something like, yeah, okay. So
you can define variables, right? You can say it's going to be the first one. Yeah.
Yeah. So
up jump.
Yeah, up jump. Up jump. Well, wait. It will output us. It's up jump mean, right? Equals to oh yeah, okay, let's put it. And if then up jump mean equals to this one, I got it. Oh no, I don't like this. It's like this. Else up jump min equals to something really big, right?
I wouldn't put else, to be honest. I would put down jump. We want to define down jump or move forward, basically.
Yeah, we want, but what happens if we are not fulfilling this? So this variable won't exist.
It's gonna have another, yeah, but you can define it already up front, right? Like you can say it's gonna be, I don't know, maximum.
Yeah.
Maximum or something like that.
Yeah, let's then define them first. Into inf. If we have numpy, I'm not sure. Maybe we can do. I think it should be imported.
Let's see, Python max number. Should be some constant in JavaScript. There is one.
Yeah, I think this is one of the ways, but I think maybe it should be done easier. So it's kind of infinity, but you need to use NumPy library.
There is a sysmax int, I see.
Sysmax int, okay.
Or sysmax size, but you also need to import it, if I'm not.
Yeah. Well, let's try to do this one. If it will not like it, then
sure.
Then we can do it. And forward move. And okay, so if then we wait. So this jump is possible, and we are going up, and we run the function from these parameters, but we also need to update these parameters for the next step.
And we do that. Obstacles also there. I think we will need to change the second param here. We will need the meaning of that, like staying on which line with the constant, but maybe not. Yeah, let's see what we got, and maybe we will figure it later. I think we just changed params here on line 20, right? Like we increased the number of jumps, we changed the line number we are currently in. So the obstacle stays the same because we stay on the same step, so all good. My previous thought was, what if we stay on a line 0, line 1, first line, and we can jump to line 1 or line 2 or line 3, sorry, in this case, and we don't have it here in the code yet.
You mean that we can jump 2 steps up?
Yeah.
Yeah. Okay. Yeah, then I guess we need to do, okay, 1 up jump. 1. Is it?
Yeah.
Up jump, yeah. Okay, let's just do jump 1.
Jump 1, jump 2, jump 3.
And 3, I guess we don't need. It's only 1.
It depends. We can define it many.
Wait, is it?
Yeah, I would maybe leave it like 3 vars, 3 variables. Jump 1, jump 2, jump 3, or move 1, move 2, move 3, and then we need to know, like, do we need a jump to go there, or we don't?
No, wait, but can it be that we can jump 3? Aren't we always having 3 lanes? So it's either...
Yeah, we can jump on any, yeah.
Yeah, so it's only 1 and 2. We're gonna jump 3.
The first lane, second lane, and third lane. So we can jump to the first one, to the second one.
You mean 2, that defines 2 where we jump?
Yeah.
Okay, yeah, I kind of defined it like how many steps we're jumping.
Okay.
I meant kind of jump 1 lane, not to the first lane, but 1 lane, like.
Okay. That's
like
interesting one.
Like up, small jump.
It's gonna be a little bit more complicated in my head, but let's see.
Yeah. Currently obstacles.
Yeah, well, both are possible, of course. I'm just yeah. Go ahead with your thought.
Maybe you're right. Yeah, I was about like to write a lot of these ifs, but you think that there is an easier solution, right?
But you are not far from my lane. It's just yeah. I think maybe we could simplify the like the algorithm with the variable names. Like, okay, we can move first lane, we can move second lane, move third lane, and we can calculate how much it would cost us to move to the first lane, to the second lane, and the third lane. So basically, if we're on a lane number 2 now, and we don't need to jump to that, right? If we don't have obstacles or something like that. But again, let's see where it goes.
Yeah. Or basically, yeah, we need only 3.
Yeah, we only have 3. Yeah, indeed.
Jump to lane 1.
And then indeed we can just have 3 variables like that. We do the minimum like you proposed, and we calculate the cost for staying on each lane, basically, or moving to each lane.
Okay. And then, yeah, okay, so if we jump piece. Jump to lane 3. So if yeah, okay, so we can do if current lane.
Yeah, all good here.
Or
yeah, continue. I think you're doing the right thing. So if current line is
yeah plus 1, then we can do jump to lane 2. Jump to lane 2. Oh, wait, but what if we do this jump from the lane 3? It will be a different.
So yeah, just I would say start from the top, right? What it would cost to you to jump to lane 1? What we need to calculate that part now. So yeah. So the cost would be if we're already on lane 1, then we don't need anything. Otherwise,
Okay, yeah.
something like that. But here you're right; it has a lot of conditions actually. Okay.
Yeah. Current lane we have it from 0 to 2, right? I forgot. Now let's have it also from 1 to 3. And so if current lane equals 1, then jump to line. So we don't need it. I'm just a bit confused. So if we are already current lane, we should just keep it, right? Because this move is not possible.
We decrease current obstacles indeed.
But why do we decrease it?
We calculate the minimum still, right? Like we move forward basically in this way, in this condition, and we decrease the obstacles because we moved forward.
We always try to move forward from the lane, yeah.
Because we want to go to the end, basically. This is our recursion.
Yeah, that makes sense. If we do, yeah, so we current jumps stays the same, current lane stays the same, and obstacles, yeah, we decrease it. Okay. LF current lane equals 2, and then jump, yeah, equals current jumps we add plus 1, current lane we subtract 1, and obstacles we also decrease. We always decrease it, right? Because we want to move forward.
No, yeah. If we just jump, we don't decrease the number of obstacles. Our step will be staying the same, and that will be the infinite recursion, right?
Yeah, but why did we decrease it here then?
Because in here we did move forward, but maybe you're right. We should move. We didn't.
I guess now we are kind of putting a lot of ifs of moving along.
Yeah. We should refactor it a little. Yeah.
Yeah, but then we always move to the next one. As I understand. I think we also have to decrease it here because we kind of first jump to the lane 1 and then we move forward, or at least try to move forward.
Yeah. Okay.
Oh, but then it couldn't be.
It could
Yeah,
be.
it couldn't be
that we
possible.
got an obstacle there, but I mean, we can also catch it and just return infinity in this case or whatever.
Yeah, but at what moment should we do it? In the beginning of the function?
Yeah, in the beginning of the function, let's say. if a current lane is an obstacle, we return maximum.
If
Yeah, it's an exercise. We can call it break your brain, break your Saturday morning brain.
curling. And then return np max.
Yeah, and np inf. Yeah.
Oh, inf. Yeah.
Yeah. That would be avoiding infinite recursion for us. And for the rest, yeah, I would just continue. I would say.
Just a reminder about time. What do you think about time?
Yeah, we have like 10 more minutes or something.
Do they need to go somewhere at 11, or it's okay?
Can wait 5 minutes, I think.
Okay. Okay, so if car lane is 2, we want to jump up. Okay, and the last one, 3, then -2. Okay, that was for jump 1. For
Yeah,
jump lane 2.
we could simplify that, of course, but yeah, that.
Yeah. For now it's a bit cumbersome.
Yeah.
So 2, oops. 2. So in the first one, if we currently on lane 1 and we need to jump 2, we do need a jump. Current lane changes to...
Yeah, just put 1 there, right? Because we know the constant where we jump in.
That makes sense. So it will always be... So there will always be, that's always the lane where we're jumping at, right?
Yeah, it's even called like that, jump to lane.
Yeah, so here it always will be 2. Here we don't need jumps because we're already there, and here we need a jump. Jump on 2. Okay, that's for this one.
Looks like it can be simplified.
yeah, because we don't need at least the last parameter. It's always the same.
Yeah.
I don't know. Oh, I didn't copy something. Oh wait, I did. Yeah. 3. So here we jump to 3. Here we jump to 3, and we also need to do a jump. Here we don't need to do a jump, and we're here. Okay, and now we need to find the mean of all these guys.
Yeah.
So mean jumps.
Oh, that's crazy algorithm. But
yeah,
maybe it would work.
I don't even know how to run it now. Jump 1, jump 2, jump 3. Okay, now we have the mean jumps, and that's what we output, right?
Yeah.
I hope. Okay, now come on. Okay, that's what we did output. To this stuff. But now we need to run it for the first time, this function, right?
Yeah.
So.
Just return calc min jumps from 0, 1, and obstacles, I would say.
Current jumps 0. 2, I guess, yeah, because we counted from
0.
I think we counted from 1.
Right. You're right.
Yeah. Current and 2 and obstacles.
Yeah.
Wait, results. We
No, we don't need this.
We don't need it. Yeah. We don't
No.
need it.
Mm-hmm. Okay.
Oh my God.
Yeah, it's quite.
Do you think it's gonna work?
It will return something, I hope.
You
Yeah.
think so? Let's try. I might drop now when I click run, but I will try.
Okay. That's funny. Let's run it. And Igor. Okay.
Syntax error. What did I do wrong? Let me put it a bit bigger. Syntax error. Elif curly 3.
Oh, you didn't close bracket. The parentheses.
Yeah, you're right. You're right.
And on other lane as well.
Yeah. Let's see here. Trying again. Here we have 3 of them. 3 of them. Okay, run. Name calc min jumps not defined. Calc min jumps.
Should be this dot calc min jumps, or is it defined?
Yeah. So. Right. We also. I guess we need to do self because.
Oh my God. And then you need to call it from line 12 and so on. Calc min jumps.
Okay, NP not defined. Yeah, I guess I have to do self. Yeah, well, let's try to import numpy first of all. NP. If it solves this error. Okay, yeah, now we need to do what you said. Jumps 9 times. We can also define it as a, I think it's called static function. Then probably don't need to do this self, but
okay.
Obstacles not defined. Did you mean current obstacles? Yeah, I think I somewhere switched from current. Yeah, it's current obstacles within this function, and I forgot about it. Oops. What did I do? Oh, what? Yeah, I'm just thinking what is easier. I guess easier is to do like this.
Yeah, and the argument. Okay. I think I might need to go.
Yeah, okay. Well, at least this out of range. Yeah, there are a lot of edge cases which have to be fixed. Yeah. Thanks a lot for being here.
Well, thanks, Igor, for your patience and will to solve this awesome task.
Yeah.
Help the frog.
Yeah, poor frog is not there yet in the destination place.
Almost there. We just need to import NumPy. I guess it's only.
Yeah. Cool. Yeah. Thanks, Alex. Yeah. Next, we should get to your piece of our code hour.
Yeah. Let's try that indeed.
Yeah.
Okay.
Cool.
Have a good Saturday then, and have
Thank
a good
you,
weekend, everyone. And please share our our channel with your friends and follow us if you like it.
grandparents.
Yeah.
Good. Yeah. So have fun.